and welcome back to Teacher Gimble's channel. Today we'll be going over Illustrative Math, Geometry, Unit 1, Lesson 7, Construction Technique 5, Squares. Let's get started. If you like this video, make sure to like and subscribe in the corner below. All right, problem number 1. Which of the statements is true? When I have one of these questions where it asks which of the statement is true, I like to see for each part if I can draw something that meets the statement and is not true, so I can cross out the answer. So that's what I'm going to do for these questions. All rectangles are regular polygons. A regular polygon is a polygon where all the side lengths are congruent or the same. Here's a rectangle. All the sides are not congruent. So no, that's not true because we have a rectangle that's not a regular polygon. All squares are regular polygons. Well, a square, all four sides are equal, no matter how you draw it. So this seems like it's correct. All rhombi are regular polygons. So a rhombus has four sides that are equal. Now, I did say that a square, the definition of a regular polygon is all the sides are equal, but I forgot to mention that all the angles have to be equal as well. In a square, we all have 90-degree angles. In a rhombus, we don't necessarily have 90-degree angles. So even though all of our sides are congruent, which is the definition of a rhombus, we don't necessarily have congruent angles, so it's not regular. All parallelograms are regular polygons. This guy's a parallelogram and clearly not a regular polygon, so we cross it out. So always go back to your definition, always make sure your definition is correct, and then just see if you can find something that's not true in the case. And that can help you solve the question. The sunlight's right up in my face. Let's go on to question number 2. Problem 2. The diagram is a straight edge and compass construction of square BACD. Not all markings are shown. The construction follows these steps. So we started with A and B. We constructed AB. We used a previous construction to construct a line perpendicular to AB passing through A. So we drew this dude. We used a compass to construct a circle centered at A passing through B. So we drew that circle over there. We labeled the intersection from step 3 as C. We used a previous construction to get a line parallel passing through C. We labeled that intersection as C. Used a previous construction of a line parallel to AB passing through C. Labeled the intersection of that line and the line from step 4 as D. Step 4, we created this perpendicular dude over here. And then use a straight edge to construct AC, CD, DB, and AB. Explain why you need to construct a circle in step 5. So, first we started from here. Then we drew this perpendicular line. Then we drew the circle. Why did we draw the circle? Well, this guy had to be the same length as this guy. And drawing the circle ensures that both edges of that square are the same radius of the same circle, so they're congruent. And that's why we needed to do it. Let's go on to the next question. Problem 3. To construct a line passing through point C that is parallel to the line AB, the first step is to create a line through C perpendicular to AB. What is the next step? So we are looking for a line passing through C that is parallel through AB. We could construct a equilateral triangle with side CD. I don't think that helps us. We could construct a line through B perpendicular to AB. So that would be this guy. I don't think it helps us so much. Construct a segment with the same length as AB with the endpoint C. So we could construct something with the same length. I don't think that's so helpful. Construct a line through point C perpendicular to CD. Well, CD is here. If I constructed a line there and he's perpendicular, those guys are the same angles, which makes them parallel. So, hey, this is the helpful one. Sometimes it's a whole lot easier to look at your answers than try to figure out the answer from the problem itself. So I went through each one, figured out that none of them were particularly useful, but when I got to the last one, I realized drawing that extra line over there gives us those congruent angles, and that creates parallel lines, which is what we wanted for this question. All right. Problem 4. Jada wanted to construct a line perpendicular to L. This is L. Through point C. It does not look like she did that. The diagram shows her construction. What was her mistake? Well, it looks like here she constructed a perpendicular bisector, which is nice. And she just didn't do it through point C. So if she wanted to do it, she'd have to create another place to construct a perpendicular bisector from, draw her circles, and do it through point C. And that's what she would have to do. So she centered her circle and used radius CA, but that didn't actually create the perpendicular bisector in the right spot. It moved it over. So she would have to use a different technique in order to make sure that her perpendicular bisector goes through point C. Problem number 5. Noah is trying to bisect angle BAC. All right. It does not look like he bisected it. He drew circles of the same radius with centers B and centers C. He then uses one of the points of intersection for his rays. Okay, that is a point of intersection. What mistake has Noah made in his construction? So although B and C are congruent, the issue here is the first step. Whenever I am drawing a bisector, first I draw a circle centered on the vertex of my original point. So in this case would be A. And then I would use B and C as the centers of my circles there, because these two segments have to be congruent. Here, he didn't draw that initial circle. These two segments are not congruent, which leads to the circles not providing the angle bisector that we're looking for. So B and C would have to be equidistant from A in order for the two congruent circles to create those intersections that we use to have a perpendicular bisector. So good try, Noah. Hopefully next time you'll get it right. Problem 6. Here is a straight edge and compass construction. Use the straight edge to draw an equilateral triangle on the figure. Explain how you know the triangle is equilateral. Well, I'm going to do the fun thing that I've been doing in all these types of questions, where I'm just going to draw a bunch of radiuses. Radius, 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 radius. Let's do a different color. That's hard to see in black. So all these guys are congruent. And now on this circle, all of these guys are congruent. On this circle, all of these guys are congruent. This seems to be getting a little bit distracting. On this circle, all of these guys are congruent. On this circle, these dudes are congruent. Hold on. I found it. This has 1, 2, 1, 2, 1, 2. Bam. There's my equilateral triangle. So I have each side is 2 radiuses, and I just use my radiuses to find more congruent radiuses to find more, and I created an equilateral triangle. And this pattern should be familiar to you now, and you should be able to find an equilateral triangle like this pretty easily. Let's go on to problem number 7, and this is our last question. Here are 2 points in a plane. Explain how to construct a line segment that is half the length of segment AB. Well, I know to get a line segment that's half the length, I can bisect it, and I'll get half the length. So let's do a perpendicular bisector. I'm going to connect them because I have AB. I'm looking for something that's half of AB. I'm going to draw a circle B, pretend that's a circle, with center B, radius AB. I'm going to draw a circle A with center A, also radius AB. Pretend that's a good circle. I'm going to connect the 2 points of intersection, and I'm going to quickly delete this because those circles were absolutely terrible. So I drew my 2 circles. These are better radiuses. I take my 2 points of intersections. I connect them. Shroom! I get my perpendicular bisector, which tells me this guy and this guy are the same length, i.e. this segment over here is half the length of the whole segment, segment AB. And I did it by creating my perpendicular bisector. All right, that's it for this lesson. It was a quick one. If you have any questions, please put them in the comments below, and I'll look forward to seeing you in the next one, which will be our last lesson on constructions. All right, see you next time.